Hello and welcome back to Daily Space Facts. I saw a very interesting comment the other day from Artbajan 123. So today we take an adventure to discuss the potential of breaking the tidal lock of a planet. Imagine a planet where one side is trapped in endless daylight, scorching hot, deserts baking under a never-setting sun. The other side? Perpetual freezing night. No real days. No seasons like we know them. Just eternal day and eternal night. This is a tidally locked world, common around red dwarf stars, the most abundant stars in the galaxy. But what if a far future civilization wanted to fix it? To give it real rotation, real sunrises and sunsets? Today, in this wild thought experiment, we're asking, could we import a massive object from interstellar space and literally spin the planet up? No planet-shattering engines, no Dyson sphere-level madness, just smart gravity control and good old tidal forces. Let's dive in. Tidal locking happens because gravity isn't uniform. The star raises huge tidal bulges on the planet, like ocean tides, but on a planetary scale. As the planet rotates, friction in those bulges steals rotational energy and transfers it to the orbit. Over time, millions to billions of years, the planet's spin slows, until one side always faces the star. Rotation period equals orbital period. For a close-in rocky planet around a red dwarf, this could mean blistering heat on the day side, frozen gases on the night side, and a narrow twilight zone where life might cling on. Not ideal for complex civilizations. To break the lock and give the planet a nice 24-hour day while keeping its orbit, you need to add enormous angular momentum. We're talking energies comparable to smashing a moon-sized body into it at high speed. Brute force? Risky. But what if we could do it more elegantly? Here's the low-tech, relatively speaking, idea for a civilization with mastery of gravity control. Think tractor beams or artificial gravity gradients. Step 1. Capture a suitable, extrasolar body. Something moon-sized to 0.1 Earth masses, dense, rocky, and stable. Tow it across the stars, and insert it into a close prograde orbit around your tidally locked planet. Step 2. Park it inside the corrotation radius, so the moon orbits faster than the planet currently spins. Now the moon raises its own tidal bulges on the planet. Because the planet is spinning slower than the moon orbits, those bulges lag behind. The gravitational torque acts like a cosmic lever. It speeds up the planet's rotation, while slowly dragging the moon inward. It's the reverse of our Earth-Moon system, where the moon is slowly drifting away. Over centuries to millennia, you tune the orbit and watch the days get shorter. Sunrise, sunset, real weather patterns. A living, breathing world. Once the planet is spinning at the desired rate, you simply tow the moon away with your gravity tech, before it reaches the Roche limit and breaks apart. Or let it form a beautiful ring system as a bonus. The alternative option is to turn the planet into a binary world. Import a near-equal mass companion, and let the two orbit each other while circling the star. Each world now gets natural rotation relative to the sun through their mutual dance. Day-night cycles without changing the spin axis much. Pluto and Charon do something similar on a smaller scale. Of course, this isn't risk-free. Get the mass or velocity wrong, and you could shatter the planet, or trigger planet-wide volcanism that boils the oceans for centuries. Orbital chaos could eject the world or destabilize the whole system, and the star will keep trying to relock it over geological time unless you maintain the companion or move the planet farther out. The total energy to move an interstellar object into the system is still Dyson sphere territory, megastructure level effort. But once it's there, the tidal method is beautifully passive. You're letting physics do most of the work instead of covering the planet in thrusters or antimatter bombs. Easier half measure? Pump a little orbital eccentricity and settle into a 3-2 resonance. Like Mercury. Slower days, but at least you get some sunrise and sunset, with far less momentum needed. In the far future, with gravity under our control, importing a companion to break tidal lock could be one of the more elegant ways to terraform, or rather terraspin, a world. It's not as flashy as building a full ring world, or enclosing a star in a Dyson sphere, but it's clever, leverages natural forces, and turns a static, half-dead planet into a dynamic, livable one. This is the kind of grand thought experiment that reminds us how much more there is to explore in the universe. Who knows? Maybe one day we'll actually do it. What do you think? Would you rather live on a tidally locked world with a twilight zone, or risk the spin-up project? Drop your ideas in the comments. Thank you to ArtBajan123. The inspiration for this video. If you enjoyed this cosmic engineering dive, like, subscribe, and hit the bell for more wild, what if science? Thanks for watching. See you among the stars.